Queen of Ireland.
Queen of Ireland. Queen of
I don't get it. No.
Please, dude.
Okay, well, actually, you'll actually get so much better.
Got number 12. We're supposed to show whether or not the function has a right half horizontal asymptote. Hands up. What are they giving us to start with? Hands up. What are they giving us? Hands. Come on. This problem is gotta get this to stick better. Ava, work. Yeah, in reality, they're giving us all of them. Like, we have to go find them one by one, but we have the ability to find every point on a graph now, every XY pair. 2 points if you knew it, 3 for Ava. When they say find the right half horizontal asymptote, you can think of it as simply doing this. You're going to plug in that x, followed by that x, forever. And you're trying to see if there is a trend. That's what finding a horizontal asymptote means. Okay? But that's a lot to write, so you've now all learned that you could write this instead. And they mean the same thing. So that green means the same thing as building a table. It really is the exact same idea. Questions? Cool. Now you have to pull some memorized facts out of your head. You have to remember, item by item, not all together, but item by item. Natural log of x. If you were building a table for just natural log of x, you've got to figure out the trend. So natural log of x. And you're plugging in values. So you got like natural log of 10, natural log of 100, natural log of 1,000. Okay. Look. Focus. Okay, you are not expected to memorize the decimal equivalents of these. All you're expected to know is the general trend. Trend means, are these values here positive, negative? Are they getting more positive? Are they getting more negative? Are they switching back and forth? Are they getting close to 0? Are they just growing and growing? Are they, what are they doing? What's the trend one to the next? That's what you have to memorize. If it helps you to remember a graph that you've seen in your past, use the graph. Here's what the natural log graph looks like. At least close enough for our class. This is the point 1, 0. This is the natural log of a whole bunch of different x's. So hands up, what's the trend right here? Hands up. Like, what are you observing here? As you go from one to the next, so Brandon King.
It's positive, like it's positive, it keeps getting bigger.
Definitely positive, because all these y values here are positive. They're definitely getting bigger. That's really all you know at this point. 3 for Brendan, 2 if your hand was raised. Andrew Thomas.
Does it get bigger at an increasingly slower rate?
I'd have to draw the whole graph to know that. I think so. Got me on that one for a minute. Don't remember. I think so. 99% sure now. So we plot ln of x. Go from 0 to like 1,000 or something. 10,000. Y values get bigger and bigger, and they do so at a slower and slower rate. But but they are getting bigger and bigger. Please.
Does that mean it has a horizontal asymptote?
All we know right now is what's happening to the top. We have to compare that to what's happening on the bottom. So 2 more for Andrew. Hands up. What's the trend on the bottom? If you make another table. Okay. Okay. Hands up. What's the trend on the bottom? Hands. Come on. There we go. Let's go, Isaac Higby.
Well, we know it's just gonna be a lot bigger and a lot faster jumps.
Well done. They're all positive, and they're all much, much bigger than the ln value. So memorize this. So 3 for Isaac, 2 for Andrew's raised. Hey, memorize this. If you have a fraction, look at me, come on. If you have a fraction, and the bottom is growing much, much faster than the top, like they are both growing. If the bottom grows much faster than the top, overall, the trend is towards 0. So this limit is 0. And this function does have a right half horizontal asymptote of y equals 0. They want to talk about that.
Can you just say that again? Yeah.
Huh? Yep.
Genius.
These are pretty common on the EP test, actually. They'll put these questions in different forms, they'll use different words, but ultimately, they'll be asking you to look at a fraction like this and figure out, as x gets bigger and bigger, what's happening to the fractions value. And it's hard to write down what's happening because the numbers are so big, but I can do kind of a simplified version and say, well, the top is growing, but it's growing very slow, just kind of little by little, but it keeps growing. The top grows so much faster. Sorry, the bottom grows so much faster, my bad. That overall, the fraction increasingly looks more and more like 0. The fraction will never actually be 0, but it does start to look more and more like 0. So that means the limit is 0. Please, Adam.
Is there a relationship similar to that, if, like for number 11? Look at it, 'cause it's basically the reverse.
Yes. So 12 was the idea that if the bottom goes a lot faster than the top, then overall the trend will be towards 0. If the opposite is true, the trend is towards either positive or negative infinity, depending on where the sign is. But
So if it's ever like that, there's automatically no asymptote.
so here, we got to be a little careful.
Yeah.
We'll talk about 11 in a second. Hold on, that's a really good question. 2 more. Anything else here? Yeah, please.
So if you take E out and replace it with any number, would the pattern be the same?
Let's write it down so we can be clear on the question. Hold on a second. We just erased the whole thing and rewrote the small part. So you said to propose a new problem to limit as x approaches infinity of what? Like what's the formula?
Log base 10.
Like what?
Log base 10.
Hold on.
So if you replace ln with log base x, or base something, and then x, and then replace e with the same number as the base, would the pattern be the same?
Oh, I got you. Like something like this.
Yeah.
Yeah, for sure. Any more? Please.
What if, like, instead of 10,
Go and talk. I can't hear.
what if instead of 10 you put like a decimal? Because it wouldn't.
So let's write it down, Simon. So let's, hold on. So this is going to be 0. What do you want, Simon? Go ahead.
Just do like natural logarithm of x over like 0.2 raised to the x.
Like this?
Yeah.
They've never asked that question. I have to go study it. I think this gets smaller and smaller. because it's less than 1, pretty sure. Yeah, for sure. So this is going to go closer and closer to 0. This is going to grow, but slowly. It doesn't matter, because the bottom's headed towards 0 so fast compared to the top. Overall, this is headed towards positive infinity. That's a good question. 4 points for Simon. They never asked that one, but that's what would happen. Laura, please. Gotcha. 3 points. Hey, look, Mark, come back. They, half of the questions on the AP test, not half of them, about 20% of them, sorry, it's not close to half. About 20% of them will require a calculator, and without a calculator, there's absolutely no way to get the point. The other 80% have to be done without the calculator. So you have some, but not this type. Limits are always non-calculated.
So with that example, if the number was bigger than, if the number was 1 or bigger, would it automatically be going towards 0 instead of infinity?
So let's make an example. Say it again, Dash.
So like if you had ln of x over just like 1 or anything.
I think any number bigger than 1, even something as simple as that, that will head towards 0. I've never seen something quite that different on the AP test, but I feel pretty confident it would head towards 0. 3 more. Please, Ben.
This is why anything below 1 will head towards infinity, because if something below 1 is multiplied by okay, I got it.
Here's what I did when I was standing at the board trying to think through it. 0.1 is really 1/10. And if you're raising 1/10 to a power, you're multiplying 1/10 by itself. So Ben, what's 1/10 times 1/10?
120, or 1. 1/100.
There we go. No worries. So we started with 1/10. Did we end up bigger or smaller?
Smaller.
Smaller. So the bottom's headed towards 0. Good call. 3 more for Ben. Please.
So, what if x is being multiplied instead of like,
Let's write it down. Hold on.
5x, or
This is a good question. Hey. 4 for Melody. Say it again, Melody. What's the top?
natural log x over 5x or 0.1x or 100x. Like, how would I know when it's
Let's
greater
do
than
whole
this?
numbers. Decimals, I don't know if they'll do that to you. 5x is very fair. This is good for the whole room. Come on, everybody. Like, this is exactly what happens on the AP test. They come up with something that's like, different than I've seen. Doesn't change the concept you're using. So, who knows what goes in the orange box? We haven't practiced it very much. I have said what happens, but I haven't practiced it much. Like, I think last time I kind of talked about the ideas that you need. A little bit harder, obviously. So, Adam.
Would it be 0?
And why?
Because we saw in that graph of natural log, it's increasing slower and slower, and 5 is increasing as constant.
Very good. And what I've memorized is the top is a log function, so it's going to grow but slow. The bottom is a power function. It is 5 times x to the first, so it's not a very powerful power function, but it still grows a lot faster than the log. So anytime the bottom grows faster than the top, we're headed towards good call. 3 points if your hand was raised. Anything else here? Really good discussion.